Hello, everyone. Thank you again for joining us this evening. For those who are joining just now, I'm Nina from Space for Impact, and we're the local organizers for the Switzerland edition of the hackathon. Tonight, we are delighted to hold this webinar on cybersecurity in space. Presenting for us will be Aris, Adamantiadis, and Xavier Mehrenberger. Aris is a cybersecurity consultant working on embedded devices and co-founder and CTO of ICON, a non-governmental organization that federates an international community working on trust in cyberspace. Xavier is a computer security engineer working on IT systems, cloud infrastructure, and embedded devices. He's also part of the ICON community. With their team Solar Wine, they participated in the finals of the Hackathon Capture the Flag. They will tell us more about their journey tonight. With this, I will pass the floor to Aris. Are you ready, Aris?
Yes, thank you. Let me just share my screen.
Perfect.
There it is. Can you see it? Great. So, hello everyone. So my name is Aris. I will speak today together with Xavier about the competition Hackathon in which we participated and in which we made a lot of very interesting things in the security. So what is Hackathon? So Hackathon is an event, it's a competition organized by the US Air Force and Defense Digital Service. So it's the US government basically, and it was part of DEFCON. So if you're not familiar with the cybersecurity field, DEFCON is one of the most famous hacking conference that hosts a lot of challenges and events to interest hackers all over the world. So this competition was made in two parts. So the first part was a qualifying event in which more than 2,000 teams participated, and a finale event in August. It was supposed to be on site, but due to COVID, it happened on premises. So basically, we did everything from home.
So that was the context for the Hackathon competition. But first, what is a CTF? A CTF is what we call a CTF is a cyber security competition where teams of hackers play against each other. They typically have to solve challenges or to hack services that have been designed for the competition. So they are designed to be hackable during the duration of the competition, which is typically a few hours or a few days. And they aim to capture a flag, that is hidden information that will be yielded by the service once it has been solved or hacked. And finding a flag brings points for the score of the team. Competitors have to learn, and what competitors gain by participating in a CTF is that they get exposed to new problems, to new tools, to new techniques, to new challenges, and they will have to think in a different way than what they are used to doing in their regular job or in their research activities. So they will have to find the flags fast. And to do that, they will have to be creative, to cut corners in order to get to the flag as fast as possible, because a fresh flag yields more points than an old one. For organizers, why would they organize a CTF? The main goal is to promote security, to develop new generations of hackers or cyber specialists, to raise awareness for the topic. And also they will get to learn how realistic attacks happen. How will a real attacker attack a system or a challenge that they design?
Yeah, sometimes it can be a bit difficult to explain how hacking something can be constructive and how we can make the field better. But it's very important to know how secure something is, that you have to attempt to hack it and to break it, because if you don't try to break it, you don't know how solid it is. So this is our team, Solar Wine. So we have members from Belgium, France, and Switzerland. So the only Belgian guy. Our team was built around friends and friend of friends who heard about the event and just wanted to participate because hacking satellites looked very cool. We did not really have the ambition to participate to the final, but well, we had a few people from our team who had already experience in CTF, and it was very captivating. So we really enjoyed participating to this event.
Our goal was just initially to have fun, as Aris said. And so the teams was made up from people that were for mostly security companies that do not have or experience with the space systems or very little experience. So the sponsors, that is the employers of the people who participated and who donated sometimes, were Airbus, Bocasset, Mehrenberger, the Icon NGO we'll talk about more later, Lexfo Security and Synactive. And yeah, we were in it for the fun, but we did not know much about space, basically.
This is us. So what is Icon? So to go very short, it's an NGO whose goal is to provide a framework to navigate inside of the digital world and digital trust, because it's a very difficult topic and field. And we try to gather a lot of experts in their own domain, which on which they can contribute to the Icon community. So the idea is that we have these experts who can help us and help others on many different topics in cybersecurity.
So you have a team of friends ready to tackle challenges for 48 hours on a weekend in May or June, I don't remember. And what are the things that we have to solve in order to learn things, have fun, and maybe reach the finale? So there were, it was not a typical IT security capture the flag where you have security challenges. There you had things that span the whole range of space-related themes. So things we did not know anything about, like astronomy, astrophysics, astrometry, astrodynamics, so computing where a spacecraft will be, or from a photo of a location, guess where it is by computing the length of the shadows and things like that. Things like identifying where a satellite is pointing by knowing which stars it can see. So we learned a lot about these real world problems that we do not typically encounter in our security jobs. There were also more things that looked more like what we're used to, such as satellite bus related challenges. That is things that happen on the communication buses between various components in a satellite. So communication protocols, how they work, what their limitations are, and what was not intended by the designers that we could exploit to reach flags typically. Also, there were challenges related to communication systems, so radio modulations or radio protocols that we could observe some dumps of radio data and had to figure out what it was, how to decode it, and there was a flag hidden in them. There are things also related to software running in ground stations. And at the bottom left, things related to payload modules, so software running on a satellite. And these ones look more like embedded devices that we are used to working. So lots of reverse engineering work. That is to say, given a program binary, that is the code that is really running on the computer, try to figure out what it does and where the problems are and how to exploit them.
Yes, if I may add, most of these problems, some of them were really untypical, but the goal for the organizers was to pick up the 8 best teams from all the participants, but also to show us the kind of knowledge that we had to learn for the finale, because all of these topics were very important for the finale if we wanted to be able to understand how the satellite was working. So for instance, the payload modules, okay, it's an embedded device that you are used to have to work on, but this device was running an architecture that is not so common, so we had to refresh on it, and all of these were very important for the finale. So these are the 8 teams that were qualified. So starting from the top, we had teams from Poland, we had teams from the US. I think most of them were American. Of course, there is our team when we reached 5th place, and we were part of the 8 qualified teams. We received a real satellite. So they sent us a satellite from the US. The story of how this satellite arrived to in France is a bit funny, but I will let Xavier tell you more about that.
Oh yeah, that was a fun one. So since we were qualified, we could receive a training satellite, a FlatSat, that is not designed to go into space, but to teach people about how a satellite works. And since this was organized by a military organization, it was really easy for them to do logistics within the US, but we were an EU-based team, and that was really complex because they had to move the satellite from US base to US base to get it to Europe and then get it to us. So it took quite some time for us to obtain it, but we finally did get it, and we could unpack it and try to learn how to pilot the satellite. So the satellite was designed to work on an air bearing, which is not on this picture. That is, it could rotate freely around a vertical axis, and there was a reaction wheel that you can spin to orient it towards the sun, that is, whose location is determined by a sun sensor at the top, so for diodes that determine where where there's the direction from which the light comes from, basically. There were also magnet torquers, so that is actuators that can push against the Earth's magnetosphere to orient the satellite. So we had to learn how to use these actuators to understand how to communicate with the satellite, to reverse engineer the communications protocols in order to be ready for the finals. Also, we had a look at the software, running on the software. So we prepared tools that are typically used. So we try to guess how to run exploits on these this exotic architecture, in order to be ready in the case that would be useful during the finals, and it was indeed useful. And then came the finals. So 2 days in the heat of August, beginning of August, I think, last year. And this time there was a story. Aris, do you want to tell us the story about the challenges?
Yes. So the idea from the challenges is not that unlike the qualification round, in which all the challenges were a bit random, in which you decide which one you solve. The challenge for the finale was a linear story. So the premise of the challenge and of the finale is that evil hackers have taken over the satellite, and we have to regain the control. To regain the control, we have to hack back. So it means that we have to get access to all the layers of the satellite operation to get control of the satellite, and ultimately take a shot of the moon. So take a picture of the moon. So the first stage was to take over the base station. So this is the piece of software, the server, where all the communication with the satellites are done. Then we had to restore the satellite because the satellite was spinning randomly in space. So we had to get access to it and give the right instruction to the satellite to stabilize and to enable good radio communication with the base station. Then we discovered that there was a malware that was blocking most of our instructions sent to the satellite, and we had to find a vulnerability inside of the malware to remove it and to bypass it. Then, of course, the camera was damaged on software side, so we had to fix it and take a moonshot. There is also another very important challenge, that was called the on-orbit. And this one was not on the satellite, the training satellite, but it was a challenge on which we had to craft a flight plan for an actual satellite that is actually in space, so it could take a real shot of the moon, so a real picture of the moon.
Exactly. So that was the scenario. And if we go to the next slide, you'll see that of course, the satellites were not in space. The flatsats were not in space. They were on a carousel somewhere in the US. And so you can see the 8 satellites for the 8 teams that are spinning around in a room. There is a projector, a very powerful light that simulates the sun, and they are rotating slowly. I think a full revolution took 15 minutes. They were powered on batteries, which caused some problems at the end because some of the teams left their reaction wheels spinning, and thus the batteries went very low, and the organizers had to change the batteries, and they lost some time. We did not have that problem, but we almost had it, I think. And then we can have a look at the scoreboard.
Yes, if I may add, we also had to deal with this spinning fact because the carousel was spinning a whole turn in 15 minutes, which means that we had windows on which we could have access to a satellite and every 15 minutes. So we had to plan so we could send the right commands at the right time, because sometimes the satellite would not be reachable.
So to comment on the scoreboard, so the first challenge was to hack a website. So we had people whose job was to hack websites that were very fast. So all of the teams, or most of the teams, scored points very quickly on this one. And then for the next, so our team is on the very first line, the one that has most points. But the second and third challenge, we were completely lost. We did not understand anything that was going on because the satellite's radio was fading randomly. In fact, we understood later that this was a simulated revolution around the Earth, and it was intentional that the satellite lost communication, but we were completely lost, and we completely missed the fact that we had to read the manual and to change the parameters of the radios, score points. So we did not score the second one. The third one, we had to send instructions, but the instructions were blocked by malware. So we tried to disable the malware, but that was what had to be done for the next challenge. We did not see that one of the commands was not blocked, and that's the one that had to be used. So we were a bit behind on score, but then we got better for the next day of the competition. So we got ready to erase the malware on the night between the two days of the finale. And then we erased the malware. That was a very fun experience where we were 10 people developing. I know that was the next one, where we had a lot of people having a look at a debugging screen to understand what was going on. Then we developed software to restore communications with the photo module. And then we took the photo of the moon. That was an operation that we had prepared for. We were ready for that. And sadly, we missed the on-orbit challenge. So they said that they would only accept the 6 first team who solved the date, and we were not as fast because it was not at all our area of specialty.
Yes, so something that was really exciting is that the taking the moonshot, fixing the camera and taking the moonshot, we did this during the last hour. And at some point we had a working camera, but taking a picture and downloading the file and seeing it on our screen, that was taking something like 5 minutes because we were not, it was very slow, and we did not have really the good means of targeting and of taking changing the attitude of the satellite to go to the moon, we did not have the time to implement that. So we took one picture and we saw the back of the carousel. We took another picture, but it was already too late because the competition was ended. And this is the picture that they sent us something like 1 hour later when they were discussing the results from the competition. They told us that we had the moon. So if you see, the quality of the picture is not very good. But if you see here, right here, there is the moon painted on the wall, which was the moon that we were supposed to take in picture.
Oh yeah, so that was a really fun experience. What we got out of it on the next slide, Aris. So we did write-ups for the challenges. So that was something that we had to do. That was part of the rules to explain how to solve it. And for the organizers, I think it was a great resource to understand how the challenges they had designed were going to be hacked during a 2-day event by attackers who do not know much about satellites. We also released some tools, technical tools that enabled studying the way the software works, so an emulator. We re-implemented the communication protocol, so technical tools that we used. And then we did presentations to talk about this experience as we are doing right now. So one on the French podcast, there was a conference in Switzerland in the beginning of 21. And this year, at the end of the month, actually, we are going to participate in the next edition, the Hackathon 2, and we are qualified for the finale in September. And also, Aris, maybe want to talk about the organization of a CTF with space challenges in the EU.
Yes, exactly. So as we tell you, we are part of ICON, and ICON is working on a CTF event that is a bit different from the regular kind of CTF that are focused on technical side. We are working on a CTF that contains not only technical challenges, but also strategical and governance challenges. So we want to have everyone around the table. So we want to have the people from the strategy and the people from the technical side who work together to solve problems. So it's going to be an integrated CTF on which we have the real scenario, and I mean, we have a complete scenario in which events will happen, and then we will have challenges that will be required to be solved to make progress into that scenario. So this is challenging, and we need contributors and also sponsors. So if you think you would be interested, please drop me an email. I'll be really pleased to tell you about it and to go further in the details. I think we have a bit more time, Xavier, so I think it would be good to explain what our solution was for the challenge. We solved one of these challenges with a solution that the organizer did not anticipate at all. So we were supposed to speak with the camera driver by sending IO request, and we used a hack, like we said before, that was shorter and faster because the regular solution was too long to implement.
Exactly. So that was for the photo. The photo capture. We were supposed to develop an application, so they provided us with a framework that had lots of pages of documentation, and as I said for the first challenge, we were not very good at reading documentation, and we did not want to waste time on that. So instead of reading how to properly write a program that would have a communication API, that it was all part of the framework, we decided to go another route. We already knew a mechanism to talk, to exchange data between the ground station and the program running on the satellite. So instead of writing something proper, we use a hack that is our program continuously read a specific address in memory to read the commands there. And so it was a bit slower than if we had done something more proper, but it was quite efficient to code that because it was really easy. It was a simple while loop. And so there was a trade-off. We could have spent more time to do something proper, but we would have completely missed the rest of the challenges. We wouldn't have had time to finish. And so we implemented this hack that took advantage of the fact that we knew a quick and dirty way to do it.
Yes, when the organizers looked at it, so they were always looking at the communication channel to see what participants were doing. They did not anticipate that because they expected that we would implement a driver and send read and write commands. But instead, they saw read and write memory commands that were very different and very difficult to follow. So they learned something is that if the hackers are working and they're hacking a device, you cannot expect them to play with your rules, and they will implement their own protocols and they will do their own things. So you cannot just expect them to use one proper channel. So in the end, they were happy to see that we used an alternative way of communicating with the satellite, because it means that maybe they are missing some stuff and they would need to improve on that.
So yeah, this underlines the fact that these challenges, these CTFs, are here to foster creativity, to get us to think outside the box, to find a solution that will work quickly, maybe not reliably, but will work quickly and allow us to get to the next stage of the challenge.
So I think that's it. Thank you a lot for following us. Xavier, maybe do you have anything to add?
Oh, feel free to reach out to us if you want to talk about it more. Would be delighted. Thank you.
Thank you very much, Aris and Xavier, for sharing with us your journey at the Hackathon CTF. We hope we motivated some of the participants who are in this hackathon right now to go further and further improve their hack skills to one day also be part of a CTF like this. This has been our session tonight for the cybersecurity in space. We hope that you enjoyed it, and we will see you again hopefully tomorrow for the next session at 5 p.m. Thank you very much.